Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome to my channel. In this session we will see ATX Green Tech 300 watt power supply, that is computer power supply ATX. This question from Nima Ismail, he sent me on my WhatsApp. So this is the message from my viewer. So he sent this diagram for explanation. Let's explain it. It is a computer power supply. It is Green Tech model MAV 300 P4. Here is input terminal 220 volts, 5 ampere fuse 250 volt, then thermistor THR1 MF72. It is surge current protection. This thermistor, either it is NTC or PTC, it will protect the circuit from inrush current. Here is MOV, it will protect the circuit from over voltage. Then we have class X capacitor CX1, class Y capacitors C11, C12 and FL1. This is our EMI filter. It will protect the next circuit from electromagnetic interference, or it will protect the circuit from any error, any noise coming from outside, or it will block all the switching errors, switching noises which are being generated here inside the ATX. So we can say it is a barrier, it is a filter. All common mode and differential mode noises will be suppressed here. A pure 60 Hz frequency with 220 volt will pass to this bridge rectifier. Here is RL207 4 diodes. AC line voltage will rectified here. The positive voltage are reaching to the positive DC rail, that is here. The negative voltage will reach here in this line, and these voltage are provided to these capacitors. Here we have two capacitors in series, 330 microfarad 200 volts and two resistors, bleeder resistors. When these capacitors are charged, it will provide the voltage to the next circuit, the same positive voltage. This time this high rail, DC rail, it is reaching here and it will not do anything. These positive voltage are reaching down here at this winding of the transformer. This is a standby transformer, the small transformer here in the ATX power supply. So positive voltage are provided here. Then we have MOSFET here, 2 and 60. So here is its oscillator circuit. It will start switching. When it will start switching, it will take a feedback. When we will take output in the output side, here we have 1N5844 rectifier. It will rectify the voltage. This rectified voltage will pass through this inductor and it will reach here at this TL431 and this voltage divider network. When we will receive exactly 5 volt here, 5.1 volt, 5.2 volt, whatsoever, with the combination of these two resistors, at that time this optocoupler will switch when the voltage are maintained. So it will pass the same rectified voltage here and it will give biasing, and this MOSFET will keep working. This C945, this transistor, it will conduct and it will start to regulate the voltage. It will control the biasing of this MOSFET and it will keep oscillating with the help of this pulse and its switching and its return signal. So it will keep switching by the help of these positive fed voltage 220 k resistors. It will give a switching level at the gate, and this negative feedback will turn off the cycle. So this turning on from this side and turning off from this side and maintaining the level by this C945, it will adjust the voltage here. We will receive 5 volt here, and the same time we have another secondary winding of this standby transformer. It is here. So this FR107, it will rectify the voltage. It is around 10 volt to 14 volt. Most of the time it is 12 to 15 volts whatsoever. So these voltage will rectified and it will stored at this capacitor, 47 microfarad 50 volts. After that 22 ohm resistor, and these voltage will reach at the VCC pin number 12 of this IC. The same voltage will apply to this pulse transformer center tape winding through this one-way conductor diode D9. So in initial startup, these voltage are reaching here and these voltage are reaching here to the transformer. These are the startup voltage for this transformer. So this time the transformer will not work, but its biasing voltage are provided here in the center tape winding. The same positive voltage 5 volt which were rectified here, these are reaching here at this point here through this diode D18. These voltage are reaching at VCC pin. The same voltage are coming outside from this point, and here it is called 5 volt standby. Here is written 5 BS, but it is 5 volt SB, 5 SB. We will receive this voltage here in the output side. The same 5 volt which are the output of the standby transformer here, which are being maintained through this R53 47K resistor. These voltage are reaching here to PD on P, to this pin. It is 7510 Supervisor IC. We will discuss in detail. These voltage are reaching here, and same voltage which are buffered through this resistor will reach here through R51 in the output side. So it is the green wire. This wire was purple wire 5 volt SB, and this one is PS on command, that is green wire. When we will connect this green wire to the ground, what will happen? At pin number 4 the voltage level will drop. Why? Because here we have 100 ohm resistor and here is 47K resistor. At this point the voltage will drop, and when it will reach to 0, near to 0, this IC will turn on. When it will turn on, it will give signal to this pin number 4, that is DTC dead time control. This is TL494. First of all, we will see 7510 WT7510. It is power supply, PC power supply supervisor. So this IC WT7510 provides protection circuit, PGO, fault protection on, power good output, fault protection on, and protection detector function. That is the PS on command signal, and it will detect the under voltage, over voltage, under voltage, and it will protect the circuit from these conditions: over voltage protection and under voltage protection. It will give some delay times between the signals. Here is PG in, PGI 5 volt input, pin number 2 is ground. It is FPLN, fault protection latch. So it will give the signal, and this is the input signal, this is the output signal to the next IC. Here we have VCC pin, which is powered up by the standby voltage and then from the 12 volt, and these are PGO, power good output. When the output 5 volt are good, it will give command to the computer that the supply is perfect. And here we have 5 volt and 3.3 volt, so these voltage will reach here. Here is pin description, and here is the block diagram of the IC. VCC, when VCC is good and PD on command is good, so at that time it will turn on fault protection latch, so next circuit will turn on. If any of these signals will become disturbed, under voltage, over voltage, at that time these computers will work and these latches, these gates will activate. At that time these will provide immediate shutdown after 73 microsecond delay. This combination will protect the circuit from any mishappening, any damage. So its typical power supply voltage are 12 volt and maximum 15 volt. What are the protection levels? Overvoltage protection for 3.3 volt, that is 3.7 to 4.1 volt. And under voltage, if this pin will drop, 3.3 volt will drop below 2.55 volts, so this IC will generate fault. If V5 will exceed from 6.5 volt or it will drop from 4.1 volt, at that time it will generate fault. Then we have VCC oblique V12. The VCC pin is the same. It is also supply pin and it is also being monitored for 12 volts. Because initially it is powered up by 5 volt, this IC, by the standby voltage. When the power supply will turn on, at that time this IC will powered up with the 12 volt. So maximum 13.9 volt. So in that case this will monitor for overvoltage protection. Now let's give a look to this TL494. It is powered up with this 12 volt, 15 volt, 10 volt, which is provided by this standby transformer. In different power supplies, its level is between 10 to 15 volts. We can say it is 12 volt. When it is provided with the supply and it is grounded at pin number 7, this IC will generate V reference, 5 volt reference. So this reference voltage is provided to pin number 13. So pin number 13 is output control. Either it IC have worked to in single-ended operation or in push-pull stage. So this time it is powered with 5 volt reference, connected with 5 volt reference. So this IC will work directly in push-pull stage in half bridge driver. So it will give a bipolar signal opposite to each other, C1 and C2. The same voltage are provided to into through this R39 and R40 resistor voltage divider network. It is provided to current amplifier input circuit. The same voltage are provided to R40 and R47K, and it is provided to voltage mod input amplifier error amplifier to pin number 2. Here it has CT and RT, 12K and 1.5 nanofarad. So this IC will receive this combination and it is grounded E2 and E1. So it will switch this ground voltage turn by turn to C1 and C2, collector number 1 and collector number 2. When someone will connect this green wire to the ground, at that time after a delay this IC will create FPL on. When it will create FPL on, at that time this pin will down. When it will down, when it will low, at that time this IC will start switching, because it is to turn on and turn off this circuit. This IC will switch, it will start to generate PWM signal at C1 and C2. It will give pulse to Q6 and Q5. These two pins are pulled up with the same voltage which are provided here, R33 and R32. The same VCC voltage. So collector 1, collector 2 are externally pulled up. So any one transistor, if it will turn on, its internal collector will turn on, these transistors will switch. Before this, when this IC is off, no collector is giving output, so collectors are pulled up. When these are pulled up, these bases are pulled up. So when these pulled up, these will not allow any signal to flow. For example, now this C1 is turned on. When C1 is turned on, it will change the biasing of this C945. At that time it will provide this voltage from this diode set to this side from the winding, and here we have positive voltage which are provided from this transformer. Positive voltage, in first time it will pass through this transistor and it will take ground from here. When this will turn on, it will give a pulse here in this transformer output side. When it will take output pulse, it will rectify through this diode, then this 22 ohm resistor, then 1 ohm jumper. It will switch this D13007 transistor. When it will switch, what will happen? Now the positive voltage are here at the collector. So this positive voltage will reach here, the portion of this winding of this transformer, and this voltage will reach here, positive voltage, and through this resonant capacitor, and it will reach to this ground, the center tip ground. Now we will see again the positive voltage from this capacitor are reaching here to the collector here. When it will turn on, at that time this positive voltage will pass through this transistor portion of the winding. The current will pass from here, positive voltage, through this resonant capacitor 1 microfarad 250 volt ceramic capacitor. So it will give a pulse and the circuit will complete its path to this capacitor. So this capacitor, about 160 volt, will discharge in this winding. One side current will flow, it will produce output in the secondary. Now check the second signal. When this transistor is switching, at that time this transistor is oppositely biased, because these two collectors, internal transistors, are working opposite to each other. So now if this C2 will couple this ground here to E2, at that time this transistor will turn on. When it was turned on, it was off. Now when it will turn on, the second will off. Why? The output of Q2 and the output of Q1 and Q2 are opposite to each other. If Q1 is on, Q2 will remain off, and after its allowed dead time, the turn off time between both channels, the second will turn on. If this is turning off here, the second will turn off after a while, after a small time, and it will give gap between the switching based on the feedback or the PWM comparator input, this dotted line. So here is the dotted line, and here is the dead time comparator control, this solid line. When it is high, the IC will remain off. When it is low, the IC will keep working, and at that time the PWM comparator feedback circuit will allow the IC to adjust the voltage. So now the output is working. When this error amplifier comparator output will change, so it will start to adjust its duty cycle from low to high, high to low. When there is no output voltage, at that time it will utilize its maximum duty cycle. When the voltage are being maintained, at that time it will minimize or it will reduce its pulse size to maintain the voltage. When the voltage will drop again, so at that time it will start to adjust its duty cycle again. So it is the total theory behind this. So Q1 and Q2 will work opposite to each other. The same will here. In first switching cycle, the positive current was passing through this transistor, and now if we look here, the negative voltage here from the bridge rectifier are reaching here at this end of this transistor emitter. Now this transistor will turn on. When it will turn on, its base will conduct. When its base will conduct, it will allow to pass this voltage, the ground voltage, to here. This time this transistor is off. Both transistors will not work the same time. Why? Because this transistor and this transistor is switching opposite to each other, and at the same time this portion of the winding is also supporting these transistors to maintain the switching gap between this and this. If this is turned on, the second will be forced to remain off. Now when the switching cycle is off, what will happen? At that time this transistor is on. Now this transistor is on. When it will on, the negative voltage will switch and the same path. Now we have to see, first the positive voltage were passing in this direction. Now the current polarity is reversed. Before that current was due to positive. Now current is in reverse direction, in the same direction of the winding. Before this the current was positive to negative, now negative to positive. So bidirectional current will flow in this winding. At that time the same path from this capacitor. Now this C1 capacitor will discharge. Before that this capacitor's positive voltage were being applied, but now the negative end is being applied. At that time this capacitor will discharge. So 160 volt, 155 volt will provided in this winding. So bidirectional current will cause to produce bidirectional current in the output side. So this switching cycle will remain working. And here we have protection diodes for both transistors. Here FR107, FR107. Now here in the secondary side, center tape winding is grounded. That is the common pin. We have two rectifiers here and one rectifier here. It is D31 F12 C20. So positive voltage out from here, from this filter, L9, this capacitor, 1000 microfarad, 16 volts, bleed resistor, and we will take output. The same time we have a DC fan. DC fan positive and negative end, it will receive voltage 12 volt and it will start to run. So it will start cooling. The voltage here from this negative terminal will come here and it will reach here, and we will take minus 12 volt from this 470 microfarad capacitor, and this bleed resistor are 74. Now we are taking positive 12 volt and minus 12 volts, and this dotted bar, it shows that this is the one filter that is wound on one ring core. From the second winding in the output side, from this winding we have D26 FR10, what is so our number, D26 and D27. This negative voltage, because this output is being taken from the anodes, so it is negative 5 volt. So we have this C41 capacitor and this resistor, 100 ohm resistor, bleed resistor, so we will take minus 5 volt. The second rectifier set, that is D7 and D8, from here we will receive voltage that is provided to PGI input, power good input signal. The same time, from the same point, we are taking output from this rectifier, that is SC20C40. It is a molded pack diode, Schottky rectifier, so it will provide rectified voltage 5 volt positive. So this 5 volt positive are provided to 470 microfarad capacitor and 1000 microfarad capacitor after a filter, bleed resistor and output. Okay, now these voltage here at this point 5 volt are provided to this MOSFET. We have P45N03L, this MOSFET. These 5 volt are reaching here. When these are reaching here, and we will take 3.3 volt regulator. How it will regulate? It have a floating regulator using TL431. It is adjustable Zener regulator, so it will provide the regulation to this gate and it will ensure the 3.3 volt output. We have this resistor network 1, 2, and it is taking feedback from the output line. A millivolt change here in the reference pin will cause to adjust the gate signal of this MOSFET, and it will switch linearly and it will produce a exactly 3.3 volt regulated output for the computer. The same 5 volt here, these are provided to V5 at pin number 6. So this is the over voltage under voltage protection pin, and the same 3.3 volt which is being taken out are provided to pin number 5. So this IC will receive 5 volt and 3.3 volts. Meanwhile, this 12 volt which are being provided to the fan and the output terminal, if we bring it here in the downside, at this point through this D20 and 10 ohm resistor, it is reaching to VCC pin. So VCC pin is being used to monitor the 12 volt. Now it will take VCC voltage from this 12 volt, and this pin is also used to monitor the 12 volt for over voltage. These two pins for under voltage and over voltage. When this 5 volt signal is correct, at that time this IC will give PGO, power good output signal. So this signal will come out from 8 number pin, and it will be provided PG, power good. So power good signal is good. If there is any error, this signal will go to PC, to the computer, that there is error in the voltage, so it will turn off the system immediately. The same 5 volt are provided here to this R71 resistor and 4148 diode D19 to the base. Meanwhile, minus 12 volt are provided to the R72 resistor. Minus 12 volt to R71, a summing point will created here, and it will control the biasing of this transistor, and a gate voltage here to pin number 6, that is V5. If any time there is something wrong with minus 12 volt or 3.3 volt, so it will cause to lower the pin number 6, because these 5 volt provided here are buffered through a resistor, that is 1 kilo ohm resistance. If minus 12 volt are missing, or there is something wrong, this transistor will pull down this pin number 6 and the power supply will shut down immediately. If there is anything wrong in the circuit at that time, it will control the operation of the power supply. Now how the circuit will regulate the voltage? This positive 12 volts, it is reaching here. If we look at this positive supply, here, and it is reaching 12 volt reaching to this network, 39k resistors, and these voltage are reaching to pin number 1, the first power supply. And if we look at this pin, it is 5 volt. 5 volt are reaching here through this 9.1k resistor. 9.1k and 12 volt from this path. 2 voltage sources are reaching here. If there is any voltage drop in any power supply, at this summing point it will adjust the voltage level to the voltage mod error amplifier. So this IC will sense the voltage, how much the output is there in the output side for 12 volt and 5 volt. If 5 volt are coming up or down, or 12 volt are going low or up, at that time this will check that there is a voltage drop here at pin number 1, so it will increase or decrease the duty cycle. turn on time to the C1 and C2, it will adjust the voltage. How it will sense the current? We are providing 12 volt here. The same voltage line, that is the center tap winding, it is provided to D11. The same voltage will provided here, and it will sense at pin number 16 of this IC, that is inverting input to error amplifier number 2. How it will sense the voltage? Because here we have a CT winding. As I discussed, all the current, positive side current or negative side current, will pass through this portion of winding. So it will give a counter EMF, reverse EMF to this primary winding. So this will cause to drop the voltage. It will cause to change the voltage here. So it will monitor the current, and this current level will apply to this one to adjust the current level. So at that time it will adjust the duty cycle to compensate the current and the voltage. Friends, I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. I will provide the link of this video in the description. You can download it. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.